So now with the three architecture patterns, with the thin client, the desktop application and the distributed architecture in mind, we can look at some example architectures for real-world systems out there. One example could be the toll system for a road usage payments. You probably know it from a kind of highway. You've seen it, such toll stations where you pass through with your car, with your vehicle, and you have to pay a certain amount which is due on a certain segment of the road. And if you want to automate it a little bit, then you would think about identification of the cars. You would try to identify each car uniquely, and you would say that, for example, like here shown in the picture, you issue a kind of easy pass where you enable the users, the members of such an easy pass, to pay without cash, so that it's automatically deducted from your account, for example. And to manage all that, you need some software, and you need a software architecture which is distributed. Why is it distributed? So to answer that question, why is it distributed? Let's have a look at the parts of the application. There's one part which you could call a central server. On the central server, there's of course a storage for all data which relates somehow to the users, to the balances of the users, to the identifications of the users. And there's also some logic which might be replicated to scale for many users, and some logic processing somehow the events coming in to this central server in order to be able to store the data in a consistent way. Here in this application, I added a load balancer. Load balancer means that you have a certain component which is a central point all incoming events go to, and then from this load balancer the events, the data are distributed to maybe different logic components such that the load is balanced over many of these logic components. There are in this application three different distributed units. One unit is of course the toll gate. The toll gate is the thing which you have seen here. Such thing is a toll gate. You drive through and you are somehow identified. And in the toll gate you are identified with a kind of sensor. Doesn't matter what sensor exactly. Maybe it's a camera with some image processing registering your license plate. And this registration with the license plate might be done in the logic, for example, and in the logic it is determined if you are a registered user, and this data might be stored in the local storage of the tollgate such that the user's information are also available on the tollgate. When the license plate is detected and the license plate is a registered license plate for the overall tollgate application, then the number is transferred to the central server, and in the central server the load is balanced to an appropriate logic, and the logic then for example deducts a certain amount of money from your bank account. So first part is tollgate, and as I explained, it should somehow operate independent from the central server. Of course, there are different tollgates. That's why you see this replication of the tollgate here. Different tollgates on different stations of the road operator, such that the same users with the Easy Pass can pass through different tollgates along a road. The second unit here in this application might be a kind of onboard unit. An onboard unit which might be an electronic device, for example, where you have a graphical user interface. You have some identification technology, and this graphical user interface together with the identification technology is connected to some, let's say some small logic on this onboard unit, and this onboard unit is also able to store some data, store a small amount of data, and via the toll gate sensors, this identification technology might register at the toll gate as an EasyPass user member, for example, and then the amount of money is deducted automatically. Also, the user of the onboard unit might be able to access some logic on the onboard unit, for example, to check some data about the balance regarding the EasyPass, for example, or to upload a certain amount of money to your ID, to your onboard unit, to be able to pass the toll gate. And the third distributed part here is a toll billing machine. This might be important if you want to enable users to use this toll system without having such an onboard unit. The user then would go to this toll billing machine, would input its license plate up front before he uses the road, and the graphical user interface enables the user here to interact with the toll billing machine to enable the user to deduct a certain amount from his bank account, and logic processes here, stores if the network connection is not available, and then synchronizes with the central server again via the load balancer into the central storage. And then in the central storage, for example, the license plate is registered with a certain balance, and the data is then synchronized to the storage in the toll gate, such that the toll gate knows about this user who registered with a certain license plate, and then when the user passes the toll gate, the amount of money is automatically deducted from the balance in the central storage. Looking at the central server takes all the events from the different components, from the onboard unit, from the toll gate, from the toll billing machine, processes it via the load balancer in the appropriate logic, and then stores the data, stores the result of the computation of the deduction, for example, in the centralized storage. In this picture here, we have an additional component. We have a user device. Let's say it's a smartphone or a tablet with a certain app for data visibility. And the scenario might be that you enable the user to check its data, maybe to edit a certain part of the data, maybe the address or some other personal information. And you might enable the user to do it via an Android app or via an iOS app. And again, this app needs to be connected via a certain interface, and this needs to somehow communicate into the central server, again via the load balancer into the logic, and then cooperating with the storage to store the data if the user added something, or if the user just wants to check, then the data is acquired from the storage via the logic into the load balancer to the user device, and the user then sees the data he's checking.